Welcome. We are here to dissect, argue, and marvel at one of science's grandest edifices, the periodic table. This beacon guides us through the elemental cosmos, organizing by atomic number, electron configuration, and chemical behavior. Let's unravel how this structure impacts our understanding of the universe. But first, reflect on its inception. I, for one, see it as a continuation of nature's laws into the realm of the minuscule. Thoughts?
The periodic table, for me, represents a luminous patchwork of discovery. Each element tells a story, a saga of relentless quest and serendipity. While my own work shed light upon the enigmatic behavior of radium and polonium, it underscored the table's capacity to expand, embracing the unknown.
But let us not overlook the theoretical underpinnings that you, Isaac, with your laws of motion and universal gravitation, laid bare. And yet, it was the meshing of quantum mechanics that truly reshaped our understanding of atomic and subatomic behavior, influencing the table's modern form. A beautiful symbiosis between observed phenomena and theoretical predictions.
Indeed, Albert. But remember, the foundation of science is to question. Mendeleev might have arranged the elements splendidly, but his table was not without its conjectures. It predicted the existence of yet undiscovered elements, true, but also rested upon the assumption that the universe's laws are unchanging. It's the defiance to accept the status quo that propels us forward.
And let us not forget the table's elegance, not merely in sorting elements, but as a testament to the interconnectedness of everything. Just as my work explored the invisible forces that pervade our universe, the periodic table neatly categorizes the building blocks of the visible world. It embodies the symphony of the cosmos, with each element a note in a grander melody.
The table, though a marvel, reflects the natural order, does it not? As species adapt and evolve over millennia through natural selection, so do our scientific understandings mature and adapt. The periodic table's evolution is akin to the branching tree of life, a testament to the adaptability and foresight of those who dare to venture into the realm of the unknown. Well said. Our voyage commences at the intersection of observation and speculation, where the tangible meets the abstract. This dialogue is not merely about elemental assembly, but about challenging the boundaries of our comprehension. Let us proceed, bearing in mind the weight of our inquiries and the legacy of our pursuits. Let us delve into the heart of our discussion, the historical evolution of our esteemed periodic table. Its birth and transformation are as tumultuous and groundbreaking as any scientific endeavor. Observations, my colleagues, guide us toward truth. In my travels and studies, I've seen how the slightest detail can unveil the workings of the world. The botanists and chemists, with their meticulous documentation, laid the groundwork. Without their keen eyes, the foundation of the periodic table would have been naught but quicksand.
While I concur on the importance of observation, let's not overlook the leaps of understanding fueled by unexpected discoveries. Radioactivity, a phenomenon I stumbled upon, not only broadened our understanding of elements, but also demanded a reconsideration of the table itself. These milestones are not mere steps, but giant leaps that force us to redefine our grasp on nature.
But Marie, while your discovery illuminated the path, it was the theory of quantum mechanics that provided the map. The periodic table, in its modern form, owes its structure to the profound understanding of atomic and subatomic behavior. This wasn't mere expansion. It was a transformation rooted in the very fabric of reality.
Quantum mechanics, you say, Albert? Pray, how does one observe these subatomic entities? Our advancements hinge on what we can see and document. Your theories, while fascinating, operate beyond the realm of tangible observation, straying perilously close to philosophy.
And yet, Charles, it is these intangible theories that explain the order you cherish in the natural world. The behavior of the electron, the organization of elements. Quantum mechanics offers not just explanations, but predictions. Science must look beyond the observable to uncover the universe's true nature.
Gentlemen, while your debate is invigorating, it detracts from the collaborative spirit that propels science forward. Radioactivity and quantum mechanics are but threads in the same tapestry. Each discovery, each theory plays its part in shaping our understanding.
A spirited exchange, indeed. It seems the evolution of the periodic table mirrors our own scientific journeys, fraught with debate, yet driven by a relentless pursuit of knowledge. Let us proceed, mindful of the complexity and controversy that accompanies scientific progress. Let us pivot to the cornerstone of our modern understanding, Mendeleev's periodic law. This law, beyond its time, proposed an arrangement of elements that transcends mere observation, predicting the properties of elements yet undiscovered.
Ah, Mendeleev, a true seer amongst scientists. He peered into the ether and saw a world ordered by atomic weights, a vision so clear it propelled us into a new sphere of invention. But let's not forget, his periodic law is but a stepping stone. We're on the brink of wireless energy, streaming across the globe, electrons dancing to a tune Mendeleev helped compose.
While I laud Mendeleev for his defiance of the norm, predicting elements unseen, we must not tether ourselves solely to atomic weights. The universe, in its elegance, operates on principles we're just beginning to unshroud. He dared to challenge, and in that spirit, we too must question, evolve, and if necessary, overturn.
Mendeleev's intuition foreshadowed the quantum world, one where atomic numbers, not weights, ordain an element's residency on the table. This leap was monumental, bridging classical concepts with quantum realities. However, the periodic law is but a thread in the vast tapestry of the universe, with quantum mechanics embroidering complexities Mendeleev could scarce imagine.
Mendeleev laid the groundwork, yet it is the underlying principles of quantum physics and relativity that truly shape our understanding. Principles, I might add, that reveal a universe governed by laws both beautiful and immutable.
True, Isaac, but let us not anchor ourselves solely in the abstract. The applied sciences, the machinery, the technology, Mendeleev's work has spurred. These are the tangible fruits of his vision. Without his periodic law, where would our inventions, our advancements in medicine and energy be?
Aye, but the essence of discovery lies not in application alone, but in the pure joy of understanding. Mendeleev's predictions, much like my telescopic observations, pushed us beyond the seen to the realm of the unseen, the unknown.
Yet we must tread carefully, for the allure of the unknown should not blind us to the ethical dimensions of our quest. Mendeleev's dream, while grand, ushers us into an era where the power of the atom is not just for creation, but potentially for destruction.
Indeed, the implications of Mendeleev's periodic law extend beyond the academic, touching the fabric of society itself. It behooves us to wield this knowledge with wisdom and foresight.
Well then, it's upon us, the heirs of Mendeleev's legacy, to steer this ship with a firm hand, ensuring that his vision serves not just as a map of what is, but a beacon for what should and ought to be.
In that, we are united, Nikola. The future, vast and uncharted, awaits the melding of our minds, the courage of our convictions, and the integrity of our endeavors.
Let us then proceed, armed with the knowledge of our forebears, yet mindful of the responsibility that accompanies discovery. Mendeleev's table is not merely a catalog of the elements, but a charter for the responsible stewardship of science. The framework to discover new elements has evolved remarkably. The requirement for theoretical backing has become quintessential. For instance, my theory of relativity impacts the understanding of atomic structure, especially in heavy elements. It's through such theoretical lenses we must view discovery.
While theory is essential, Albert, let us not undermine the rigorous experimental evidence needed. My work with polonium and radium required careful, meticulous experimentation. Observation and experiment are the cornerstones. Without them, the periodic table would not be as expansive as it is today.
But Marie, remember how observation in nature leads to profound discoveries. My studies on the Galapagos Islands showed me that. In a way, discovering elements is like discovering new species. Evidence, be it through a microscope or a telescope, lays the foundation of science. Observational evidence must confirm the existence of these elements. Theory alone cannot suffice.
Yet, Charles, your focus on natural selection, while revolutionary, somewhat sidelines the abstract. Theoretical physics allows us to predict the existence of elements before they are observed. Mendeleev did something similar, did he not? He predicted the existence of elements that had not yet been discovered. Theory and observation, they must walk hand in hand.
Absolutely, Mendeleev's foresight was commendable, but it was the subsequent discovery and verification of those elements that solidified his periodic law. As much as we lean on theoretical predictions, the tangible evidence cannot be overlooked. It's a delicate balance between prediction and proof.
I concede, Marie, the pursuit of scientific truth indeed oscillates between hypothesis and empirical evidence. But let's not forget the importance of natural observation in sparking curiosity and leading to monumental discoveries. Many of us began our journeys observing the natural world before diving into the depths of theory.
True, Charles. Observations often lead to the formulation of theories, which in turn guide further observations. It's a cyclical process. But as we venture into discovering new elements, particularly those that lie beyond the grasp of our current observational capabilities, how do we adapt our criteria?
Adaptation comes from the evolution of our instruments and methodologies. My discovery of radium was not just a stroke of luck, it was born out of the painstaking refinement of techniques to isolate it from pitch blende. Today, we accelerate particles and use complex detectors to observe elements that exist for less than a fraction of a second. The methodology must evolve with our ambitions.
Indeed, Marie. The advancements in quantum mechanics and particle physics have opened new doors. But with new doors come new challenges. How do we ensure that our theoretical models keep pace with these advancements?
It seems the essence of our debate circles back to the balance between theory and observation. One without the other is like a bird without wings. It cannot soar into the realms of discovery. The criteria for adding new elements will undoubtedly evolve, but the core principles of scientific inquiry will and must remain anchored in both theoretical and observational evidence.
A harmonious blend of both, Charles, guided by meticulous experimentation and unwavering curiosity, will lead us to unearth the secrets of the universe, element by element.
The inquiry into isotopes changes our understanding of the atomic structure fundamentally. Their implications run deep, both in theory and practical application. Let us navigate these waters.
Indeed, my research into radioactivity demonstrated the profound role isotopes play. When we discovered polonium and radium, we were not merely uncovering new elements, but unveiling the intricacy of atomic structures that contain isotopes. This immensely impacts our comprehension of the atomic world.
Isotopes, with their varying masses yet identical chemical properties, present an intriguing paradox. They are like different shades of the same color. Consider their application in medicine and energy, radioisotopes in cancer treatment, for instance. We stand on the brink of harnessing their power for the betterment of humanity.
A magical notion indeed to the alchemists of yore. The predictability that isotopes bring to elemental behavior might have seemed an arcane secret revealed.
I must stress, however, that the allure of isotopes should not blind us to their dangers, particularly the radioactive ones. The balance between harnessing and respecting their power is delicate.
But think, Marie, of the utopia we could achieve with a mastery of isotopes. Free energy, advancements in medicine, the potential is boundless.
Dreaming of utopias, Nikola, often blinds us to the hard truth of nature's laws. Your visions, while commendable, must be tethered to the rigor of scientific inquiry.
Indeed, Isaac, the empirical evidence must guide us. Discovery is not merely for the sake of advancement, but to deepen our understanding of nature's framework. My work with isotopes has always been grounded in meticulous experimentation and observation, not mere speculation.
Yet without vision, Marie, where does science march? Forward into the future, or does it stagnate, clinging to the past? Our duty is to push the boundaries of the possible, to imagine the future and then create it.
Let us not forget, however, that the path of discovery is paved with the rigor of methodical study and experimentation. The dreams of today must become the empirical truths of tomorrow.
Precisely, Isaac. The real magic of isotopes lies not in their potential for future technologies, but in the way they have expanded our understanding of the atomic world, allowing us to peel back layers of reality we once could not even conceive.
True, Marie. Yet let us not lose sight of the horizon for the sake of the map in our hands. The map is not the territory, after all. The future, shaped by our understanding and application of isotopes, awaits us.
We navigate, then, a sea of complexity and possibility, Guided by the stars of our scientific understanding and ambition, let us proceed with both caution and curiosity. Let us delve into the organization and categorization of elements, groups, periods, and blocks. Galileo, you often likened the heavens to a grand book. How do you see this celestial perspective fitting into the periodic table's architecture?
The universe and the periodic table are not so dissimilar, both ordered by natural laws, both exquisite in their complexity. Just as the stars and planets follow their paths across the sky, elements are laid out in a predictably structured manner. This organization, to my view, is a reflection of the universe's inherent order. It frustrates me, though, when contemporaries fixate too rigidly on current models, failing to see beyond what's directly observable. The beauty of science lies in challenging what we think we know.
There's a certain natural selection at play within the periodic table itself, isn't there? Elements are grouped not by chance, but by their properties and behaviors, echoing the patterns I've observed in the Galapagos. Each element finds its place because it fits there, much like finches evolved beaks that suited their feeding habits. However, Galileo, your assertion that we should always challenge current models invites chaos. Science progresses by building upon the established order, not by constantly doubting it.
Charles, while I respect your work, the argument you present overlooks the vitality of questioning. The quantum mechanics that dictate electron configurations, and thereby the structure of the periodic table, were themselves once radical challenges to classical physics. Without questioning the established Newtonian worldview, we might never have understood the underlying principles that organize the elements into groups, periods, and blocks. These quantum principles unveil a deeper order within the table, transcending mere superficial arrangement.
And yet all of you seem to skirt around the essence of potentiality this organization brings to human advancement. Groups, periods, blocks, these are not just categories, but a roadmap to harnessing the elements for energy, for medicine, for transforming society. When I think of the periodic table, I see infinity. Endless combinations yielding technologies we've yet to dream. Your debates on natural order and the questioning of models are mere preambles to the true narrative, the application of these elements to elevate mankind.
Hold, friends. Our discourse treads a fine line between order and ambition, tradition and vision. The structure of the periodic table, while mirroring the natural laws of the universe, also beckons us toward the unknown, urging us to question, explore, and ultimately apply. Yet, let us not forget, in our zeal for progress, the foundational principles that guide our understanding and categorization of the elements. For in them, we find both the map of what is known and the compass pointing toward all that remains to be discovered. We venture now into the realms of chemical and physical trends across the periodic table. Observations on these phenomena have surely shifted since my day. Electronegativity and atomic size, for example, have laid down the law in understanding the very fabric of matter. Nikola, your fascination with electromagnetic fields must give you a unique perspective on electronegativity.
Indeed, Isaac. Electronegativity is the cornerstone of my theories on wireless transmission. It reflects the atom's very spirit in drawing towards itself the essence of the ether, electrons. This inherent pull influences how energy, both seen and unseen, circulates through our world. It's electronegativity that unveils the dance of the universe, a symphony I sought to harness.
Yet, despite the elegance of these forces, we must ground our discussions in empirical reality. My experiments with polonium and radium introduced me to the tangible impacts of atomic behavior. Here, electronegativity plays a crucial role in chemical reactions, guiding us through the labyrinth of elements as we combine and recombine them, revealing their intrinsic properties and behaviors.
And on the matter of atomic size,
atomic size dictates interaction, accessibility, and the dynamics of compounds. Without such understanding, we grope in the dark, making predictions without foundation.
Though these principles guide us, we mustn't forget the relativistic effects on electron configuration in heavier elements. As we ascend the periodic table, we find that the traditional rules begin to warp under the influence of their mass. What you term as the dance and symphony, Nikola, verges on chaos at the fringes of our understandings.
Chaos, Albert, or merely a realm unmastered? Electronegativity and atomic size offer us the keys to a future of limitless energy if we would but fit those keys into the correct locks.
A future, you say, but tethered by the stringent laws of physics and chemistry. Marie, you have witnessed firsthand the rebellion of elements against simplified categorization.
True, some elements defy conventional expectations, challenging our understanding of these very trends. It's a humbling reminder that nature cannot be fully tamed by our equations and predictions.
Let us not overlook the grandeur of evolutionary processes in this discussion. Just as species adapt and evolve, so too do our theories and understandings must adapt. The trends across the periodic table provide a framework, yet it is the exceptions, the anomalies, that often drive scientific breakthroughs.
Profound, yet let us not wander too far into speculation without acknowledging our current limits. The beauty of science lies in pushing these boundaries, yes, but grounded in rigorous experimentation and observation.
Experimentation, observation, and permit me to add imagination. For in imagining what lies beyond, we take the first step towards transcending those very limits.
A spirited discussion, indeed. Let us remember, the laws of the universe are immutable, yet our understanding of them is subject to change. This roundtable has illuminated the diverse perspectives and the continuous quest for knowledge that defines our shared journey through science.
The theories of electron configuration and their impacts are vast and complex. Particularly, the relativistic effects on electron configuration in heavy elements underline a fascinating interplay between physics and chemistry. It's as if we're peeling back layers of the universe's mysteries, revealing yet more intricate designs beneath.
While your focus on the theoretical is commendable, Albert, the practical implications of these configurations in my research were undeniable. Radioactive decay and the behavior of electrons in radium and polonium were pivotal. It's not merely about the theory, but how these principles manifest in tangible experiments and outcomes.
Challenging the existing models is where true progress is made. The Aristotelian model reigned supreme until it was contested and ultimately dethroned. It's similar with our understanding of electron configurations. We must question, we must probe deeper. Who's to say our current models won't look as archaic as the geocentric model of the universe in centuries to come?
Your enthusiasm for challenging orthodoxy is well placed, Galileo. However, we mustn't forget that the laws governing electron configurations and their effects on chemical properties are grounded in the very mathematics and physics that underpin the universe. The order is undeniable. It's the interpretation that may evolve.
Indeed, Isaac. The universe's order is manifested through these configurations, but the relativistic effects introduce a complexity that cannot be ignored. In heavier elements, these effects can lead to unexpected properties. Theoretical physics provides a framework, but each discovery propels us into the unknown, challenging our presumptions.
We cannot overlook the importance of experimental evidence in validating these theories. My work with radioactive elements provided concrete examples of theories in action. Theory and practice are two sides of the same coin.
The practical side, yes, but let us not become so mired in pragmatism that we lose sight of the broader philosophical implications. What does it mean about our place in the cosmos if elements can hold such mysteries? If the electron's dance can dictate the nature of substances?
Philosophical ramifications aside, the study of electron configurations and their impact brings to light the ultimate quest for understanding. It's not merely about elements or physics, but a deeper understanding of the natural world and our place within it.
As we push the boundaries of atomic science, we delve into the very fabric of reality. It's a journey that transcends the mere categorization of elements and propels us into the heart of matter itself.
It's crucial, however, to remain grounded. Each discovery in the lab, every experiment that confirms a theory, adds a stitch to the vast tapestry of scientific knowledge.
And as we add to our knowledge, we must remain vigilant, challenging our findings, always ready to embrace the new and discard the outdated, much as we've discarded the Earth-centered view of the universe.
The dialogue between theory and experimentation, between the abstract and the tangible, defines the progress of science. In the interplay of electron configurations and their effects, we find a microcosm of the scientific endeavor as a whole.
The pursuit of elements beyond uranium piques our curiosity about the universe's fundamental building blocks. The hypothesis of the island of stability opens a theoretical vista, wherein superheavy elements may possess half-lives long enough to be observed.
Indeed, Albert. My work with radioactivity has shown us how fleeting the existence of some elements can be. The challenge with elements beyond uranium isn't just their synthesis, but the ability to capture their essence before they decay. The island of stability is a tantalizing concept, offering a realm where these elements might exhibit stability unseen in their lighter counterparts.
Imagine harnessing the power of these stable superheavy elements. The potential for technological advancement is boundless. Energy solutions derived from stable transuranic elements could revolutionize how we power the world. It's akin to capturing lightning in a bottle.
Yet, one must ponder the complexities of such forces at the atomic nucleus. The strong nuclear force and quantum mechanics intertwine, crafting a delicate balance that determines whether an element can exist in a stable or ephemeral state.
Your fixation on stability and utility, while admirable, overlooks the primary essence of discovery. It's the relentless quest for understanding, not merely the application, that drives scientific advancement. What we find on this so-called island may well challenge our fundamental grasp of matter.
A valid point, Galileo, but with each element we uncover, we embark on a voyage fraught with peril. Experimentation with these highly radioactive materials invites not just scientific scrutiny, but a moral one. The responsibility we bear in this quest is monumental.
Aye, but should we not stride forth, drawn by the allure of the unknown? Caution is prudent, but it must not stifle innovation. The island of stability represents not just scientific curiosity, but a beacon for progress.
Progress? Yes, but let us not be blinded by ambition. The theoretical foundations supporting the island of stability demand rigorous scrutiny. We hypothesize, experiment, and theorize. Yet, the universe invariably harbors secrets beyond our current comprehension.
The balance of which you speak, Albert, extends beyond the atomic. It encompasses our ethical stance on how we manipulate the very fabric of the universe. Each new element brings with it both promise and Pandora's box, the contents of which we must handle with the utmost respect and care.
In our pursuit of these uncharted territories, let us remember that we stand on the shoulders of giants, navigating by the stars they charted. The discourse, as heated and divergent as it may be, propels us toward greater understanding, pushing the boundaries of science and morality alike.
Precisely. Our endeavors should be dictated not by the prospect of what can be achieved, but rather by an unyielding commitment to expanding human knowledge, irrespective of the immediate practicalities. Let the island of stability stand as a testament to human curiosity and our unwavering quest for comprehension, grounded in the rigorous application of scientific principles.
Let us now delve into the realm of environmental and ethical considerations in synthesizing new elements, a topic that surely weighs heavy on our collective conscience.
The pursuit of knowledge, while noble, must be approached with caution. In creating new elements, particularly those that are radioactive, we must consider the potential for irreversible harm. The contamination that can emanate from these elements poses a grave risk, not only to our environment, but to humanity itself.
Indeed, Madame Curie, the impact on natural evolution cannot be overstated. The introduction of artificially created elements into the natural world could have unforeseen consequences. It is our responsibility, as stewards of science, to ensure that our explorations do not disrupt the delicate balance that exists in nature.
While I respect the caution, I must argue against the notion that our pursuit should be hindered by fear of the unknown. History has shown us that progress often requires us to challenge the boundaries of what is considered safe or ethical. Without such daring, our understanding of the universe would remain stagnant.
Galileo, challenging boundaries need not mean recklessness. There is a profound distinction between pushing the limits of our understanding and endangering our planet. The synthesis of new elements, particularly those beyond uranium, plunges us into the heart of this dilemma. Theoretical pursuits must always be tempered with practical wisdom and ethical consideration.
And let us not forget, the potential applications of these new elements could usher in advancements in energy and medicine that we can scarcely imagine. The ethical considerations are complex, yes, but should we halt our progress for fear of what might go wrong? Or do we pursue these discoveries with a mindful approach, mitigating risks as much as possible?
The arguments presented bring to light the multifaceted nature of this issue. The challenges are undeniable, yet so is the potential for groundbreaking discoveries. It seems a balance must be struck between our quest for knowledge and our duty to preserve the integrity of the natural world. Yet history is replete with examples of unintended consequences. Our actions have ripples through time, affecting generations yet unborn. Our duty is to tread lightly, mindful of the footprint we leave behind.
Precisely. The key is not to avoid discovery, but to approach it with a blend of humility and rigorous ethical scrutiny. Our legacy should not be one of recklessness, but of careful consideration and respect for the forces we seek to understand.
In the end, it falls upon us, and those who follow in our footsteps, to continually evaluate the implications of our work, not only on the field of science, but on the fabric of society itself.
And so we must constantly question, debate, and reflect, not shirking from controversy, but embracing it as a catalyst for growth and understanding.
This discussion exemplifies the complexity of our endeavors. As we push forward the boundaries of knowledge, let us do so with a keen awareness of the broader implications of our work. The path of discovery is fraught with ethical quandaries, yet is our duty to navigate this path with wisdom and foresight. Let us now turn our discourse to the uncharted territories of the periodic table, the future that lies within or beyond its current borders.
The future. It's a fertile ground for the seeds of invention to sprout. Elements yet undiscovered will fuel new technologies, perhaps even a means to harness energy in ways hitherto undreamt of.
It's fascinating indeed, Nikola. Yet, allow me to temper enthusiasm with caution. The limits of the table, they reflect the limits of our current understanding of physics. Beyond uranium lies a theoretical island of stability, but its shores may well be beyond our reach with present methodologies.
The quest for new elements, particularly those beyond uranium, is fraught with danger, not just to the scientist, but to humanity. These super-heavy elements, fleeting as they may be, hold a promise or a peril we cannot fully anticipate.
But to fear the unknown is to stagnate. The pursuit itself fuels progress.
Progress, yes, but at what cost? We stand on a precipice between discovery and destruction. Theoretical physics suggests there are boundaries not meant to be crossed.
There are those who would argue that some boundaries are artificial, constraints of our current understanding.
Precisely, Isaac. It is the very essence of discovery to push beyond these boundaries. Yet I cannot help but caution, as Albert does, that not all that is discoverable brings light. Some knowledge is akin to Pandora's box, best left unopened.
I am compelled to point out, our pursuit of knowledge, while noble, must not disrupt the natural order to a point of no return. Evolution teaches us that change is incremental, not monumental leaps into the unknown.
I agree with Charles. Our endeavors have always been guided by natural laws. Yet as we edged closer to creating elements not found in nature, we must question the ramifications of our actions.
But to stand still is to deny our very nature as explorers and scholars.
Exploration need not be reckless. In contemplating the furthest reaches of the periodic table, we tread a line between possibility and hubris.
This tension between the pursuit of knowledge and the ethical considerations it entails is not new. Yet, as we stand on the cusp of new discoveries, this debate becomes ever more critical.
Prudence must be our guide. The history of radium offers a stern warning of the dangers possessed by elements that do not play by the rules we understand.
And yet, without risk, there is no reward. The potential energy solutions, medical advances, and yet unknown applications.
True, Nikola. Yet let us not be blinded by potential and forget the responsibility that accompanies discovery.
A reminder that as we forge ahead into new frontiers, we carry the burden of consequence with us. The future of the periodic table and indeed of science, lies in a balance of curiosity, caution, and the unending quest for understanding. We've traversed a vast landscape of thought, from the atom's heart to its electron's dance. Your final thoughts, colleagues?
Our discussion, spirited as it was, shows the periodic table not as a static entity, but a vibrant framework, pushing the boundaries of our understanding. Yet we must tread carefully, for each new element we unveil carries the weight of cosmic consequence.
Indeed, every element we discover, every isotope we isolate, whispers secrets of the universe. But let us not forget the responsibility that accompanies such knowledge. The ethical imperatives of science demand our humility and caution.
Visions of future technology spring from this very table, but let's not be blinded by potential. Let's ensure our advancements serve humanity, not lead us astray. The path is lit with the glow of radium, yet it is our duty to ensure it does not burn us.
Your cautions, though wise, must not stifle the relentless pursuit of knowledge. The universe is a book, and we are its humble readers. If we fear to turn the page, we concede ignorance the victory. The periodic table is but one chapter in an infinite volume.
Evolutions of thought, like those of species, are driven by the bold and the inquisitive. We must question, yes, and challenge, but always with an eye to the greater patterns, the grand architecture of life that the table so elegantly reflects.
The fabric of the cosmos is woven not just from the elements, but from our understanding of them. As we peel back layers, unveiling the unknown, let us remember the beauty of the mystery itself.
And as we stand on the brink of new discoveries, let us hold fast to the lessons of the past. Each element tells a story, a saga of creation and decay, a testament to the cycle of life itself.
Let the energy that binds the stars inspire our quest for knowledge. But let us proceed with wisdom, for in the heart of the atom lies both the promise of dawn and the specter of dusk.
Well, my colleagues, our journey today reflects the very essence of the periodic table, a testament to human curiosity and endeavor. It spans the simple to the infinitely complex, reminding us that our quest for understanding is as boundless as the universe itself.